Good day, everyone, and welcome to where we are putting together solutions for students who are struggling in this math channel in the area of additional mathematics, which seems to give some students a lot of problems. In this paper, we'll be specifically looking at May 2024, the paper 2. This is a subject which is presented under the Caribbean Secondary Examination Council's banner, the CSEC exams. Don't forget to like the video and add any comments down below so that we can help create other content in areas of additional math that you are struggling with. If you look at the description down below, we have posted videos from 2012 when additional mathematics in this area started until present. And they are for the first 10 years, they are by the 4 sections. So in the first section, you will get 10 solutions from 2012 onwards, listed in 2 different videos from 2012 to 2016. All of algebra questions are in one video, and then from 2017 onwards, all the algebra questions there are posted. So in 2 videos, we cover all the questions in the first section, and similarly for the second, third, and fourth sections, there are videos for each. From 2023 onwards, we have started by giving videos of the complete past paper. So the description down below suggests that you look at what is additional mathematics and study in the order where when you're doing a topic, you do all the past papers, at least the first 10 years, or go through them in the videos on that particular area. That strengthens your content and understanding. And only then you start to look at complete past paper questions. Now, remember that we also have a channel for CSEC Mathematics, which started even earlier than this channel in 2009 onwards, with the same format of all 17 topics, videos on each of them, notes on them, and of course, after a period of time, we started doing complete past papers. And we also have a channel for primary math as well. So let's now look at the overview of how this assessment is done in additional mathematics. So we call that for this section, there are 4 areas. And from 2023 onwards, right, they are complete solutions. So this paper is assessed with paper 1 being a short answer, or specifically a multiple choice paper with 45 questions. Paper 2 is worth 100 marks. So let's now look at the first section, which is algebra, sequences, and series. This actually consists of quite a few mini topics, the first being algebra, then quadratics, followed by inequalities, functions, surds, indices, and logarithms, and finally sequences and series. So these 6 topics actually contribute to the content in section 1. In terms of assessment, the paper 1 or multiple choice paper, there are 20 questions that cover section 1 out of the 45. 2 of them are on algebra. 3 questions will be coming on quadratics. 2 questions on inequalities. 4 on functions. 5 on surds, indices, and logarithms. And 4 on sequences and series. In terms of the long paper, paper 2, when it is being assessed, it will be in questions 1 and 2. You will see the assessment, and it will be worth 30 marks, 15 marks each for for question 1 and for question 2. You'll see this format will be followed throughout. Then we move on to the second section, which is coordinate geometry, vectors, and trigonometry. And the subtopics in here that make up the section are all 3: coordinate geometry, vectors, and, as listed above, trigonometry. In terms of assessment in the multiple choice, this section 2, there are 14 questions that come in this area. 3 of them will be on coordinate geometry, 3 of them will be on vectors, and 8 of them will be on trigonometry. In paper 2, there is 1 question, which is question number 3, which assesses the section 2, and that is worth 20 marks. We now move on to the third section, which is introductory calculus. And in terms of that will be broken up into differentiation, integration, and kinematics. In terms of paper 1, there are 5 questions that will be based on differentiation and 6 on integration. None will be done on kinematics. So 5 and 6 will give us 11. If we total now 20 and 14 is 34 and 11, 45. That means all the multiple choice questions are based on those topics identified. So there will be no multiple choice questions on the 4th section. And in terms of assessment in paper 2, introductory calculus will be tested in 2 questions, number 4 and 5, each worth 15 marks, giving a total of 30 marks. And finally, for the last section, probability and statistics. As stated previously, there are no questions in paper 1 on that area. And in paper 2, the subsections will be probability and statistics. And in paper 2, it will be 1 question, number 6, worth 20 marks. So if we total the marks in paper 2, 30 and 20 is 50, 30 and 20 is 50, 50 and 50 is 100. So that covers the view of how the analysis and sections are in additional math. Do not forget, there's another paper, paper 3, also known as the SBA, School-Based Assessment. Right, let's actually move into the paper. So we'll be looking at May 2024, number 1A. Determine the other linear factors of the polynomial 3x cubed plus 8x squared minus 20x minus 16, given that x minus 2 is a factor. So if we consider this equation as a whole, we could realize that the highest power of x is 3, which means that this is a cubic equation whose general form looks like this version from the top, where it moves from negative infinity to positive infinity, or the reflection of that. That's the general form of a cubic equation. Or if the equation, when you add terms in x squared and x to the power 0, then it may actually look a little more stretched out, like the ones on the right-hand side. So a little manipulation. What tells the difference between which type of graph it falls under is the idea of the coefficient of x cubed. The coefficient of x cubed, let's identify that as a. If a is positive plus, then it looks like one of the graphs on top. And if it is negative, it looks like the reflection of it. If we look at this equation that we're dealing with, it's 3x cubed, that expression, not equation, there's no equal sign. We see that the coefficient of x cubed is 3. As such, that's positive. So it means that we're only looking at one of the top 2 graphs in the general form of this equation. Something else to note, that when we consider what is a factor, it means that we are able to identify that there's a root, meaning that our cubic equation cuts the x-axis at some particular point. So if we notice that x minus 2 is a factor, then the x-axis could be at this point, which means that it's cutting at only one root. Or there's only one root if the x-axis is above. So either the green line or the purple line will indicate where the x-axis is if there's only one root. However, if we look at the question again, determine the other linear factors, which means that there is not only one root, but more than one. So there's a possibility that there are three roots, which can be indicated as this red line. And this is a quick review that you've done with your teachers already. What is indicated here is that it cuts on the left side once, and there's a double root where there's that minimum point. So in a case like that, it may be indicated as x plus 3, as an example, squared. So that the root is actually 2 of the same values. Or it may be 3 distinct roots, meaning it's cutting the x-axis at 3 different points. So it'll either be a view of the red or the black. And this is just a brief overview. Since we know that it has other terms in terms of x squared and minus 20x and minus 16, then it will be the one on the right-hand side. Let's now let that expression f of x be equal to that, 3x cubed plus 8x squared minus 20x minus 6. And we know x minus 2 is a factor. And there are quite a few different ways to solve it at this point in time. One of them is by the long division method, which for some of my students, they are having problems recognizing that. So another method which I found to be a little more lenient and easier for my students to grasp will be the recognition that if we multiply the factors, it will give us the expression. So if we consider f of x, that will be the factor x minus 2 multiplied by the other two factors. And if we multiply by two other linear factors, it will give us a quadratic. So what we're going to do now is try and solve for that quadratic. And when we get the quadratic equation, maybe we're able to identify by factorizing or quadratic equation what the other two roots are, meaning what the other two factors are. So if we look at this multiplication, we have a linear x minus 2 by a quadratic, right? And there are many ways to do it. I'll just do it in a method which is quite visual for those who do not like the abstract method. So we have ax squared plus bx plus c, and we'll think of this like an area of a box. And if that is the length, multiplied by the breadth, and the breadth would be x minus 2. So if we consider as one rectangle, a large rectangle, we subdivide it into these parts, we have 3 terms on top by 2 terms, 6 different terms, which means we're going to break up this box into 6 parts, as indicated in this diagram. So if we multiply for the area of the top box on the left side, ax squared times x is ax cubed, and then plus bx by x is plus bx squared, plus c times x is plus cx, minus 2 times ax squared is minus 2ax squared, minus 2 times bx is minus 2bx, and minus 2 times c is minus 2c. So we can indicate this as 3x cubed plus 8x squared minus 20x minus 16. And we can recall that we wrote it as a linear multiplied by a quadratic. And when we multiply those terms, what happened was we were able to get 6 different individual terms. So ax cubed plus bx squared plus cx minus 2ax squared minus 2bx minus 2c, which comes right from the box method. And if we look at like terms, there's only one term with x cubed in it, so that's ax cubed. But there's a term with x squared in it, which is plus bx squared. And there's another term with x squared in it, minus 2ax squared. So those two terms are like, we've indicated in yellow in the boxes. Anything else that is like terms? Yes, we have the term with x in it, cx, and we have the term with minus 2bx in it. So we've recognized now that we have a ax cubed, we have two terms in yellow, which are similar, or like terms, we have two terms in green, and then we have minus 2c. So let's write it in that order. So ax cubed plus bx squared minus 2ax squared, the two yellow terms, plus the two green terms, minus 2c. And then we're going to be able to factorize out the x squared. So that gives us ax cubed plus, when we factor out the x squared, we're going to get b minus 2a. And we do the same with the x term. So we're going to c minus 2b x minus 2c. And now we can compare this fifth line to the top line by looking at equivalence in terms of what the coefficients are. So by the principle of undetermined coefficients, we know in terms of the cubic values, ax cubed in the fifth line is the same as 3x cubed in the top line. As such, if we divide throughout by x cubed, then we'll recognize that we've solved for a. A is equal to 3. Let's do the same now for the terms in x squared. So we have b minus 2a x squared in the fifth line, in the bottom line there, is equal to what's on top? Plus 8x squared. And if we divide through by x squared, we're going to get b minus 2a is equal to 8. And we know a is equal to 3. So we can substitute for that. B minus 2 3's equal to 8. We just solved for a. So b minus 6 is equal to 8. As such, b is equal to 8 plus 6, which means b is equal to 14. I'm trying not to skip steps so students can follow for those who are getting problems. And then we solve for a and b. We need to now solve for c. And we know the coefficient of the term with x to the power 0 is minus 16 on the top line, and it's minus 2c in the bottom line. If we divide through it by minus 2, on the left-hand side, it will give us c. On the right-hand side, we will get plus 8. As such, we solve for a, b, and c. So f of x is the linear times the quadratic, and we can now substitute. So we're going to get x minus 2 by 3x squared plus 14x plus 8. And at this point, you can take the quadratic equation and factorize it. I know you can do that, so we'll leave that working out. And that will give us x plus 4 and 3x plus 2. As such, if we look at the original equation question, determine the other linear factors apart from x minus 2. So we got the other factors. Look in yellow, x plus 4 is a factor, and 3x plus 2 is a factor. So we've solved for this part 1. And what that means is that we have 3 different or distinct roots, as the 3 factors are all distinct. As such, if we look at the black and red arrows for the x-axis, it clearly, if there's 3 different roots, will be the black line. So we could remove the red line. And that is what the general sketch of the graph will look at. Let's now go on to part 2. Hence, meaning using the information we've just gotten from part 1, simplify the following multiplication. 3x cubed plus 8x squared minus 20x minus 16, which actually looks like f of x, which we've just done, all over x squared minus 4 is equal multiplied by x plus 2 over x plus 4. Well, we can rewrite this by putting in brackets so students can easily identify it. And we recognize that f of x can be rewritten as 3 factors, x minus 2 times x plus 4 over 3x plus 2. And we can also recognize x squared minus 4. If we factorize that, will be x plus 2 by x minus 2, the difference of squares. Now, when we here, if we think about multiplying fractions, what we do at this point in time is try to reduce, or some people say cancel out. So is there anything similar in the numerators and denominators? Let's see. There's an x minus 2 in the numerator, and there's an x minus 2 in the denominator. So we could cancel those brackets. What else is there? There is a x plus 2 in the denominator and an x plus 2 in the numerator. So we've reduced 4 terms. Anything else? We have 3 terms left. Yes, we have x plus 4 in the denominator and x plus 4 in the numerator. As such, we reduce 6 of the terms. We've been able to cancel out, leaving us with the answer as being 3x plus 2. So we are able to simplify the multiplication. Let's now move on to May 2024, number 1b. The equation kx squared plus x minus 15 is equal to 10 has roots alpha and beta, where k is not a whole number. Sorry, where k is a whole number. Let's recall that if we consider 1, 2, 3, 4, 5, those are natural numbers or counting numbers. And if we want whole numbers, we now have to include the 0 in there. So 0, 1, 2, 3, 4, 5 will be key. And recognizing that, then that gives us a hint into what our answer should look like. So part 1, determine the expressions for the sum of the roots, alpha plus beta, and the product of the roots, alpha beta. So when we're looking at that quadratic equation, let's make sure that when we're manipulating it, that one side is equal to 0, which means that we need to minus 10 from both sides. If we minus 10 from the right-hand side, we'll be left with 0. And we minus 10 from the left-hand side, we'll be left with kx squared plus x minus 15 minus 10, which is minus 25. And from a quadratic formula standpoint, the coefficient of x squared, we consider it to be a. So a is equal to k. The coefficient of x is normally known as b, which in this case is plus 1. And the coefficient of the term with x to the power 0 is minus 25, and that's indicated by c. So the sum of the roots, alpha plus beta, is, you would have done this in class with the proof with your teacher, would be equal to minus b on a, so I don't have to do that here. And b, we can substitute as 1, and a is k. So the sum of the roots, alpha plus beta, is minus 1 on k. And now we're going to determine alpha beta. So the product of the roots, which is c over a, and we know c is minus 25, and a is k. As such, we now move on to part 2. Given that for the sum of the squares, alpha squared plus beta squared is equal to 61 over 4, use the expression in b part 1 to determine the value of k. So it means that use the ideas that alpha plus beta is equal to minus 1 on k, and alpha beta is equal to minus 25 on k to help us solve for k. So let's recall that alpha plus beta all squared is alpha squared plus 2 alpha beta plus beta squared. We can multiply this out, alpha plus beta times alpha plus beta, and that will give us our left-hand side. And if we rearrange it a little bit so it looks like the information that we have, then let's remove the 2 alpha beta from the left-hand side by minusing on both sides. So we can get alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha beta. Some teachers say, well, we carry it across and change the sign. Okay, that'll work as well. So alpha squared plus beta squared from above is 61 over 4. Alpha plus beta, we know that as minus 1 on k, so we will square that. And alpha beta, we also know that, so we substitute for each. And then we have a squared, so we can expand that. Minus 1 on k times minus 1 on k is 1 on k squared. And to simplify this, to make it a little more palatable and easier for us to recognize, we can multiply throughout every single term, left side and right side, by k squared. So it'll give us 61 on 4, k squared is equal to 1 plus 50k. and we can multiply throughout by 4 to get rid of anything in the denominator. So we'll get 61k squared is equal to 1 times 4 is 4, plus 50 times 4 is 200k. So 61k squared minus 200k minus 4 is equal to 0, because when we are solving for quadratic equations, we want to make one side equal to 0. Unfortunately, at this point in time, this cannot be solved by factorizing. So we'll have to use the quadratic formula, which is simple enough. A is the coefficient of k squared, which is 61, b is equal to minus 200, and c is equal to minus 4. So from the quadratic formula, which we know is k is equal to minus b plus or minus the square root of the determinant, b squared minus 4ac, all over 2a. We can simply substitute for the values where b is minus 200, so it's minus 200. And in square root, we have minus 200 squared, which works out to be 40,000, minus 4 times a, which is 61 times minus 4, all over 2e, 2 times 61. So that's 40,000 minus 976. So that gives us 40,976 square root. So we have two answers. We either have k is equal to 200 plus that, or 200 minus 40,000, the square root of that. So when we look at the negative, 200 minus that, it gives us approximately minus 0.02. If we think about that, the values that were given in third line, it was k, right? That direction at k must be a whole number. 0, 1, 2, 3, 4. Cannot be negative, cannot be a decimal. So if k was to be the answer and we try to approximate it to a whole number, then it would approximate to 0. If we did that and we looked at the original equation, kx squared plus x minus 15 equal to 10, then with k being 0, it would mean that it's no longer quadratic, but as x minus 15 is equal to 10, which is more linear. And if it's linear, then you will not have more than one root. So it does not work when k is equal to 0. Clearly, it has roots alpha and beta, two distinct roots, so that would not be possible. We'll have to ignore that answer. The other answer is when we do addition, 200 plus the square root of 40,976 divided by 122, and that works out to be approximately 3.3. Again, this should have given us k as a whole number, 0, 1, 2, 3, 4, and so forth. So the most we can do is approximate 3.3 to the nearest whole number, which is 3. Now when doing this, and I substituted back that into the equation up on top, let's say 3x squared plus x minus 15 equal to 10, and I solved for it, I found the roots are approximately minus 2.41 and plus 2.07. Those would be the values of alpha and beta. And if we added those two values, it would give us minus 1 on k, or minus 1 on 3, approximately. So it holds for the sum of the roots. But if we did the product of the roots, where we multiply those two values that I got as the roots, right, it would not give us minus 25 on k, so it doesn't work. And if we substitute for alpha squared plus beta squared, it does not give us 61 on 4. As such, there's clearly something wrong with this question. So it seems that there has been some sort of error in it. Now, teachers can easily recognize this, but I'm sorry that students are going to have a lot of problems because they wouldn't recognize that there's an error in the paper. And some of my students were quite frustrated with this. So let me correct for what I believe was a typographical error by looking at the question slightly in terms of the fact that the new equation, or how it should have been as far as I recognize it, would be that it's equal to 0, not equal to 10. Right? So the typographical error would be that there was an extra 1 here to make it look like it's equal to 10. With that little change, everything else holds, right? there's no reason to have any 10 across. It's already equal to 0. Then the A and B values are the same. It's just the C value would move from minus 25 to minus 15 now. The sum of the roots, alpha plus beta, will still hold. And the product of the roots, which is C on A, will be now minus 15 on K, not minus 25 on K. So there's a little change in it. If we now go on to part 2, where they're giving us the alpha squared plus beta squared equal to 61 on 4, we can do the same expansion and simplification. So when we substitute, the only difference, alpha beta is not minus 25 on K, it's minus 15 on K. And when we expand the squared, multiply throughout by K squared, just as we did before, and then multiply by 4, right? It becomes palatable. The only difference is the last term on the right side, which was 2 15s 30. Previously, it was 50, 2 by 25. So when we correct for this, we'll eventually end up with 4 by 30 is 120 key instead of 200 key. When we bring this across, we now recognize that this can be factorized, and the factors are 61k plus 2 and k minus 2. So for a quadratic equation to be having factors equal to 0, it means that either the first factor, 61k plus 2 is equal to 0, which means that k is equal to minus 2 on 61. And clearly, from the third line here on this, you'll see that k must be a whole number, which is 0, 1, 2, 3. K cannot be negative, so this will not hold. Or if we take the second factor, k minus 2, that means that k is equal to 2. And that is a whole number. So unfortunately, this typographical error happened, but this would be the proper solution. So let's now move on. We've just completed 1b. So now let's look at number 1, part C, where in this equation, it says for the quadratic formula, 5x squared minus 4x plus 2 is equal to jx. Determine the exact value of the maximum point and the range using the completing the square method or otherwise. So g of x is equal to minus 5x squared minus 4x plus 2. We know that's an inverted graph because the coefficient of x squared, which is minus 5, because it's negative, means it's going to have a maximum. And stating that, we can now factorize that out, the minus 5. So we're left with x squared plus, because we're removing the minus 5, plus 4/5 x plus 2. And of course, some teachers guide their students to the fact that we can now memorize these formulas and solve. That's fine. For the students who are getting problems, this is done by, I'm sure many of your teachers use algebra tiles and shows you how to solve this. So let's look at what is in the curly brackets. We have x squared plus 4/5 f. And we can break that up into, we have minus 5 times what's in the curly brackets, x squared, x times x, and 2/5 x and 2/5 x, which gives us 4/5 x plus 2. Right? There are quite a few schools where doing algebra tiles from Form 1, so students can practically see what this is and recognize that algebra does not have to be taught abstractly. It can be visual or concrete if you have the tiles to work with. Right? So let's see. We want to complete the square, which means we want to make a square. So let's pull out an x squared here. And if we want to make a square, let's look at the 2x on 5 or the 2/5 x. Right? The square grows a little bit. So to make a next one, we have to put it on the base. And we basically have a square. We're missing a little portion in the corner. We know that right now we have a length of x and 2/5. So x plus 2/5 on one side, and x by x is x squared, and 2/5 on the other side. And if we do some multiplication as if it was area, we see 2/5 times x is 2/5 x. So what is missing? That portion will be 2/5 times 2/5. 2/5 times 2/5 is 4/25. I'll bring up a green one to indicate such. And if I add 4/25 and I add minus 4/25, I'm not really interfering with the value of the equation. It gives us 0. So I can move that 4/25 into here. And of course, we have to move this with it because we're not changing the total value. But what happens now is we now have a square. So for that portion, we were able to see what was in the curly brackets. It's x plus 2/5 all squared minus 4/25. So that shows the indication of the curly brackets. And of course, that could be repeated a second time, and a third time, and a fourth time, and a fifth time, according to what the coefficient is. So the coefficient is -5. That means what we've done is we are able to look at what is inside the curly brackets, x squared plus 4/5 x, and rearrange it to make it into some sort of square, because we're trying to complete the square. So in a case like that, don't forget that we have the +2, so let's put that on the side here, 1, 2. So now we can rewrite this whole thing. We have -5 times x plus 2/5 squared minus 4/25 plus 2. So my students who are accustomed with using algebra tiles, this is quite straightforward. They do this in a couple of minutes. The other students who are accustomed to memorizing the set of rules and applying it, all right, you could go with that method as well. That's fine. Right? Just showing you a different aspect because this is supposed to be taught like this. And if we multiply now by the -5, right, then we will be moving the curly brackets, and -5 times minus 4/25, that gives us 4 5s are 20/25 plus 2. 20/25 is 4/5 plus 2 is 2 4/5. So we've actually rearranged the equation from the form on top in gx minus 5x squared minus 4x plus 2 to be in the form of completing the square. -5 times x plus 2/5 squared plus 2 4/5. And now for the next part, determine the value of x for which f of x is a maximum. Since this has a coefficient of -5, we already recognize that the shape of this graph is an inverted U, so there will be a maximum, and we need to know what value is going to be a maximum. So for this equation to be a max, what is inside of the brackets, x plus 2/5, must be equal to 0. So that will mean that x plus 2/5 is equal to 0. So x is -2/5. And that will be the value. The next part of the question is asking us, what is the range of g of x? So g of x is equal to -5 by x plus 2/5 all squared plus 2 4/5, that equation we had. And let's bring up the graphs so you could see the general principles of what it looks like. And we noticed just now that at the value that we have in x, the line of symmetry or the axis of symmetry or the mirror line occurs on the second out of 5, so on -2/5. When x is -2/5, that will be a maximum. And of course, we know just from quadratic information that equivalent distances from the line of -2/5 will be the roots, which is 1, 2, 1, 2, 3, and a piece on the right, and same on the left. But this question doesn't ask for roots. And what happens in terms of the maximum value of g of x? That occurs at the maximum point. We'll indicate that with a purple line. And that means that happens when the brackets 0. So when x is -2/5, g of x is 2 4/5. Hopefully you could see that from the graph. And they want the range So how do we think of the range? The range would be all the y values in which this graph occurs, which would be starting from the maximum and coming downwards until infinity. So therefore, the range will be from for plus 2 and 4/5 and goes to infinity. So the range is g of x is less than or equal to 2 and 4/5. It includes 2 and 4/5, so there's also an equal sign there because that's the maximum point, and going downwards. Okay, we finished number 1, which was worth 15 marks. Let's now move on to number 2, which is still in section 1, still under the areas of algebra and a host of other topics. So number 2, part A, we're looking at, this is specifically the area of Surds, indices, and logarithms. Write the expression 2 log x to base 3 plus 2 minus log y to base 3 as a single term. And if we look at that, in order to manipulate easily, let's rewrite it. We would like to somehow make everything to the same logarithmic values or base of 3. So let's look at 2. 2 is really 2 times 1. 2 ones are 2. And if we recall, 1 can be represented as any log with a base of itself. So log a to base a is equal to 1. Or if this was reverted into indices, a to the power 1 is equal to a. Recognizing that, we can now convert it so all of this equation looks like a log to base 3. So it'll be 2 log 3 to base 3, because log 3 to base 3 is equivalent to 1. Now, if we look at the idea that when we have a logarithmic term and there's a coefficient in front of it, then we can move that coefficient k up so it becomes the power. So k log a to base log b to base a is equal to log b to the power k times a. And if we look at our first term, 2 log x to base 3 falls along that line, so we can bring the 2 in up to get x squared, and we can do the same thing with the second term to get 3 squared. So we have log x squared to base 3 plus log 3 squared to base 3 minus log y to base 3. And of course, 3 squared is 9. So we have log x squared to base 3 plus log 9 to base 3 minus log y to base 3. And if we have two terms that are being added, two logarithmic terms, then we can combine them with a multiplication according to the rule log BC. So if we multiply 9 and x squared, we're going to get log 9x squared to base 3 minus log y to base 3. And if we have two logarithmic terms with the same base and there's a subtraction between them, then we can combine them to a division. So we'll have log 9x squared over y to base 3. And that is writing this entire 3 terms as one single term. Let's now move on to part B, part 1. By using logarithms, express the relationship v is equal to 7 times 5 to the power t in linear form. So let's rewrite it and apply logarithms to both sides. So we have log v is equal to log 7 times 5 to base t. When there's log alone written, it's understood it's to base 10. So the 10 is not required. And if we have log of a times b, right, then we can separate it out according to this rule. So log 7 times 5 to the power t can be rewritten as log 7 plus log 5 to t. And if we have a log to a power, 5 to the power t, then we can take that power and put it in front. These are the same rules we applied on the left-hand side. And what will mean is that we can move the t to the front of it. So it's t times log 5 is equal to log 7. If we look at this line, we recognize that log 7 is a constant, log 5 is a constant, the variable is t, and that will cause log v to vary. So we can rewrite it if we want to put it like log v is equal to log 5, a constant, times t, a variable, plus log 7, which is a constant. Let's go on to part 2. Hence, state the value of the gradient of the line, which represents the relationship. So, if we have such, remember, the general equation of a straight line can be represented as y is equal to the gradient of that line times x plus c. And they're asking for the gradient. The gradient would be log 5. Let's now move on to the last part of number 2, which says rationalize the denominator of the expression 1 plus root 2 over 3 minus root 2. Let's rewrite that, and we call that when we're thinking about rationalizing, we really want to take the denominator, as it was indicated above, and multiply by the change of sign. So 3 minus root 2, we want to multiply throughout by 3 plus root 2. So if we don't want to change the value, then we really have to multiply by 3 plus root 2 on the numerator and the denominator, because that actually reduces to 1. So if we multiply by 1, we don't change the value. However, by doing this multiplication, we'll change the form. So just to recall, for multiplication purposes, I know you can do the roots. We're just looking at the denominator multiplication, right? 3 plus root 2 and 3 minus root 2. When we multiply that, 3 3s are 9. 3 times root 2 is plus 3 root 2. Minus 2 times 3 is minus 3 root 2. And minus root 2 times root 2 is minus 2. So remember that 3 root 2 plus 3 root 2 and minus 3 root 2, they both have root 2 in it. So that will actually give us 0. So we'll be left with 9 minus 2. That will be the multiplication of the bases. So when we think about rationalizing, what we're really doing is trying to put it into a form where a plus b times a minus b, a squared minus b squared, right? And those squares mean that we remove the surds in the denominator. So when we rewrite this, it'll be 1 plus root 2 times 3 plus root 2 all over, what's the denominator? 9 minus 2. There are no surds there anymore, which means that we can simplify. 1 times 3 is 3, 1 times root 2 is root 2, plus 3 times root 2 is 3 root 2, plus root 2 times root 2 is 2. All over 9 minus 2 is 7. So 3 plus 2 is 5, and 3 root 2 plus 1 root 2, just like 3 marbles plus 1 marble is 4 marbles. So we get 5 plus 4 root 2 all over 7. And we have rationalized this expression. Let's move on to an evaluation, where we're looking at finding the sum of the terms from I is equal to 0 to I is equal to 4, which means when the first term, the term at 0, the term at 1, 2, 3, and the term at 4. So those 5 terms, where each term is represented by 5 to the power of I minus 2. So if this is the general term, and we're finding the summation of 5 terms, when t to the power 0, meaning I is equal to 0 is the first term, that's what the summation says, then we substitute in for I as 0. So t to the 0 is 5 to the 0 minus 2. 0 minus 2 is minus 2. 5 to the minus 2 means 5 squared, and it's negative, so it's 1 over 5 squared, which is 1 over 25. T to the 1, we do the same. So it'll be 5 to the 1 minus 2, which is 5 to the power minus 1, which is 1 over 5. T to the 2 is 5 to the power 2 minus 2, which is 5 to the power 0. Anything to the power 0 is 1. For t to the power 3, then we substitute in 5 times 3 minus 2, which is 5 to the power 1. Anything to the power 1 is itself. So it's 5. And do we have an next term? Yes, we have up to 4. So for t to 4, 5 to the power 4 minus 2, which is 5 to the power 2, or 5 squared, which is 25. So the summation from I is equal to 0 to 4 is really adding up 5 terms. T0, T1, T2, T3, and T4. And we have those values. We could substitute 1 over 25 plus 1 over 5 plus 1 plus 5 plus 25. 25 and 5 is 30. 30 plus 1 is 31. And we have 1 over 25th plus 1/5, which is 5 over 25th. So 5 over 25 plus 1 over 25 is 6 over 25. So it's 31 and 6 over 25. Right? I usually encourage my students to do this as fractions and not convert to decimals, because sometimes we have to end up rounding off and we're no longer accurate. But many times the fractions are quite accurate. So in the last part of the equation, this question, part E, determine whether the following sequence is divergent or convergent. And we have to justify our answer. So the sequence is 1 as the first term, minus 2/3 as the second term, so it became negative. Then 4/9, then became positive, and then minus 8 over 27, so it's fluctuating in terms of sign. So could this be an arithmetic progression? Well, if it was, then with our arithmetic progression, there will not be constant fluctuation between first term and second term and alternating terms. They would either all be increasing or all decreasing. Right? So it doesn't look like it's a arithmetic progression. Let's try a geometric progression. If it's a geometric progression, it's multiplying by some value, which is called the common ratio, or R. So if we take the second term, and we're assuming it's a geometric progression, that is a to the r, and we divide it by the first term, which is a, then when we divide, you're going to get r. So that's all been done by your teachers in notes. So we're just going to substitute t to the 2 minus t to the 1, a to the ar over a leaves us with r. So minus 2/3 divided by 1 is minus 2/3. Does it hold for the next two terms? T3 divided by T2, 4/9 divided by minus 2/3, it's still minus 2/3. It still holds. Does it hold for the next two terms, the third and fourth terms? T4 minus divided by T3 still gives us minus 2/3. So what we recognize here, there's a common multiplication factor, better known as a common ratio, and that ratio is minus 2/3. Since if we look at that common ratio and we look at the absolute value of that absolute value is 2/3, meaning that we ignore whether or not it's positive or negative, that the absolute value is less than 1. Anytime the common ratio is less than 1, it implies that the series is convergent. And if you would like to look at what the summation to infinity, s to infinity, is for this particular series, the formula for that is a over 1 minus r. We know a is the first term, which is 1, over 1 minus r, which is 1 minus 2/3, which is 1 plus 2/3, which gives us 5/3 in the denominator. 1 over 5/3 is 3 over 5. So clearly, it converges to 3/5, the summation. We've now completed section 1. Let's go on to section 2, which is number 3 in this area of coordinate geometry, vectors, and trigonometry. Part A is speaking about determine the points of intersection of the line x squared plus y squared minus 4x plus 6y plus 8 equal to 0, which indicates it's a circle, and the line y is equal to x minus 6. So let's indicate this here. I've highlighted y in green because we have y is equal to x minus 6. Let's bring up the graph of what this equation actually looks like. You won't have this in the exam, but you could work it out if you wish. But this is just to show where these lines lie. So that first line looks like this, where we have the center at x of 2, a value of 2, and y value of minus 3. Right? So it gives us that same equation there. Now, we know y, which we highlighted in green, is x minus 6. So we're going to substitute for that. That's why I highlighted the green, so you can see where the substitution is going to take place. X minus 6 squared, and then 6 times x minus 6. And if we expand that, we're going to get x squared plus, what is x minus 6 squared? X squared minus 12x plus 36, minus 4x plus 6 times x is 6x, minus 6 times 6 is 36, plus 8. And we can now simplify. X squared plus x squared is 2x squared, minus 12x minus 4x plus 6x plus 36 minus 36 plus 8. So we have 2x squared minus 16x plus 6x is minus 10x, and 36 minus 66 is 0. We're left with 8. 2x squared minus 10x plus 8 is equal to 0. So I've kind of drawn the line here to show you that, but we'll come up with that just now. And we can make this a little simpler by dividing throughout by 2 every single of the 4 terms there. 2x squared we could divide by 2, minus 10x we could divide by 2, plus 8 will divide by 2, and 0 will be divided by 2. So that will give us x squared minus 5x plus 4 is equal to 0. And you can solve by quadratic formula, or we can factorize. I'm factorizing here, so x minus 4 by x minus 1. I didn't show you that. I just assume that you're able to factorize, or use the other formula. So either of these are linear factors of this quadratic equation, meaning that either x minus 4 is equal to 0, which implies that x is equal to 4, or x minus 1 is equal to 0, which implies that x is equal to 1. Stating that, then what happens is we're now able to indicate that when x is equal to 4, we can substitute using a linear equation, because that's simpler than the quadratic. Right? Y is equal to x minus 6. So y is equal to 4 minus 6, which means that y is equal to minus 2. So when x is equal to 4, y is equal to minus 2. That will be one point of intersection with a straight line. And when x is equal to 1, the other term, we know the same equation, y is equal to x minus 6. So y is equal to 1 minus 6. As such, y is equal to minus 5. So let's draw that line here. And we can see at 4 minus 2, our first points of intersection, and at 1 minus 5, your second point of intersection. So we can easily tell that the straight line intersects the circle at these points. Let's now go on to 3, part B. Given that the coordinates of the points A and B are 7 minus 3 and 2, 1, respectively, say the position vectors corresponding to the points A and B in the form xi plus yj. You're using the unit vectors I and j, I being unit vector in the x direction, j being unit vector in the y direction. So the position vector for OA is 7 minus 3j, because the x value is 7 and the y value is minus 3. And I'm putting up a little sketch here so you get a grasp of what's happening. So if we just make a little sketch, then from O, which is your origin, or the intersection of the x and y axes, you can draw a line 7 to the right and 3 down, and that will give us what OA represents, that vector. That's the position vector there. And then for OB, it's 2i plus 1j, because it's 2, 1 are the Cartesian coordinates. Part 2, determine AB, that vector. Now, how do we go from A to B? We can go from A to O, and then from O to B. So A to O is really the opposite direction of OA, so it's minus OA plus OB. And we know the values in terms of the unit vector, so we could substitute. So AB is minus OA, which is 7i minus 3j plus 2i plus 1j, minus 7i plus 2i, I'm grouping the like terms together, 3j plus 3j plus 1j, so minus 7i plus 2i is minus 5i plus 4j. So if we start at A and we're going to B, we're actually moving 5 to the left and 4 up. So we're moving 4 upwards. So the change in y, if we're using a right angle triangle to indicate such, right? So that means it's plus 4j and it's 5 to the left, so it's minus 5. Now let's look at part 3. calculate the value of the scalar product OA dot OB. Now, using the idea of scalar product, what do we know? OA dot OB would be the A1, A2, the first coordinates of OA and OB, plus B1, B2, the second coordinates of OA and OB. When we say first and second coordinates, we mean the x coordinate and the y coordinate, or in this case, the I and the j factors. So we could write them as column vectors if you wish. 7 minus 3 for OA and 2, 1 for OB as given. So we're multiplying the x terms or the unit I terms. So it's 7, I have it in red, and 2 in black. So you can see that's what we're multiplying. 7 2s are 14. And then the j terms or the y terms, minus 3 times 1 is minus 3, 1. So 7 2s are 14 plus minus 3. And the scalar product works out to be 11. Let's now move on to number 3, part C. Right? Using the letters P, Q, or R, write an expression for each of the following trigonometric ratios. And they gave us this diagram, recognizing that within the diagram that there was a right angle here. So we're dealing with a right angle triangle. They indicated that the angle is theta. And they also indicated that the sides are labeled P, which is the opposite to the angle Q, the longest side or the hypotenuse, and R, the adjacent side. And they're asking us to find sine theta. So sine theta is, from trigonometric ratios, the opposite side over the hypotenuse. That's the ratio. The length of the opposite side, which in this case is indicated by P, over the length of the hypotenuse, which is represented by Q. So P over Q is equal to sine theta. Similarly, for cos theta, the trigonometric ratio would be the adjacent side over the hypotenuse, which works out to be R over Q. Now that's C part 1. Let's go on to C part 2. Using your answers in C part 1, which are sine theta and cos theta, determine the value of sine squared theta plus cos squared theta. We call that sine squared theta is sine theta all squared. So if we look at sine squared theta plus cos squared theta, that is sine theta squared plus cos theta squared. And from above, we know sine theta is P on Q. So we're squaring that plus R on Q squared. And that means P on Q squared is P squared over Q squared plus R squared over Q squared. Right, let me just rewrite it here a little higher, the exact line, so you can follow on the right-hand side. And both of these share the same denominator, Q squared, so it can be rewritten, if you wish, to look like P squared plus R squared all over Q squared. And by Pythagoras' theorem, because it's a right angle triangle, that the sum of the two perpendicular sides, the squares of them will be equal to the square of the hypotenuse. So P squared plus R squared is equal to Q squared. So we can substitute for that. So Q squared is the numerator and Q squared is the denominator, and they will reduce to 1. So sine squared theta plus cos squared theta for any angle is equal to 1. Let's go on to part T. In this one, they're asking us to prove the trigonometric identity. Tan A plus 1 on tan A is equal to 1 over sine A cos A. So we can use any side and manipulate it until we get the other side. I usually ask my students to take the more complicated looking side, which in this case would be the left-hand side. So let's recall the left-hand side is equal to tan A plus 1 over tan A. And what is tan A? Sine A over cos A plus 1 over sine A over cos A. And if we look on the right-hand side, 1 divided by a fraction, it really means we write it as a reciprocal, right? So 1 divided by sine over cos A is 1 times cos A over sine A, or just simply cos A over sine A. So now we are actually adding two fractions. Let's consider them S and C plus C over S. Then when we're adding them, we need to get the LCM if you want to use that method, or the common multiple, which is sine A cos A, and cos A into sine A cos A, right? is sine A, and sine A times the numerator, sine A plus cos A cos A. Sine A times sine A is sine squared A plus cos A is cos squared A. And from the fact that we just proved that in part 2, that works out to be for any angle, sine squared A plus cos squared A is equal to 1. Then that is equal to 1 over sine A cos A, which is your right-hand side. So we have proven it, which can be written as a small square box to show that we have shown the proof, or the Latin phrase QED, which means quod erat demonstrum. Let's now move on to number 4. And we're looking at the third section now, which is calculus. Use the definition of the derivative as a limit to f bar x for the function f of x equal to x squared minus 3. So f bar x, or f prime x, is equal to the limit of f of x plus h minus f of x over h, where h tends to infinity. H being the very small incremental change. Right? This is by first principles. So we know f of x is given as x squared minus 3. If we want to find, we're moving x to x plus h, a small incremental shift. So wherever we have x, we're going to replace it by x plus h, typical functions method. Then it'll be x plus h squared minus 3. And if we expand that, x plus h squared is x plus h times x plus h, which is going to give us x squared plus 2hx plus h squared minus 3. So if we look at the numerator, f of x plus h minus f of x, if we substitute for that, it will be x squared plus 2hx plus h squared minus 3 minus f of x, which is x squared minus 3. So if we move the brackets, it will be multiplying by minus 1, so we'll get minus x squared plus 3 at the end. And we have x squared minus x squared, and we have minus 3 plus 3 equal to 0 as well. So we're left with 2hx plus h squared as the numerator. So we can also factorize out the h. So we get f of x plus h minus f of x. The change in the function's y value with this small incremental shift of h is h times 2x plus h. So if we substitute and we look at this limit here, the difference is h by 2x plus h all over h. So the h is reduced. So we have the limit of 2x plus h as h tends to 0. But h is going to 0. So if h is going to 0, it disappears. So we're just left with 2x. As such, f prime, or f bar x, given that f of x equal to x squared minus 3, is equal to 2x. Now for part 2, they're asking us to hence determine the value of f double prime 5. So f bar x is equal to 2x, which we just worked out. And I'll do it by first principle still, even though you can do it other methods as we're practicing this. So we have 2 times fx plus h minus 2x, which is 2x plus 2h. Remember what's happening here in that line is x is being replaced by x plus h. So it's 2 times x plus h minus 2x. And when you expand that, you're going to get 2x plus 2h minus 2x. Of course, the 2x minus 2x is going to be removed. We're left with 2h over h. And the h's will be removed. So we're just left with 2. And what's the limit of 2? No matter what h is? Well, that doesn't change, so it will be 2. So if we want to find f double bar x, it's 2. And it doesn't matter what the value of x is. 0, 1, 2, 3, 4, in this case 5, it's still going to be f double bar x equal to 2. All right, let's now move on. As we finish that first part of the question to number 4, part B. Given that y is equal to sine over x, sine x over cos x, show that the differential of that is 1 over cos squared x. So let's use a substitution. Let's consider that y is equal to u over v. Then when we're differentiating a quotient, then we're going to get v du dx minus u dv dx all over v squared. Now, what is u according to y there? U is equal to sine x, which implies that du dx, the differential of sine x, is cos x. And what is v? V is what is in the denominator, which is cos x. So if v is equal to cos x, dv dx is equal to the differential of that, which is minus sine x. Now that we have u, v, du dx, and dv dx, we can simply substitute into the differential of a division. So let's go. dy dx is equal to v, which is cos x, times du dx, which is cos x as well, cos x by cos x, minus u, which is sine x, times dv dx is minus sine x, all over cos x squared, because v is equal to cos x. So cos x times cos x is cos squared x, minus sine x times minus sine x is plus sine squared x, all over cos squared x. And as we did previously, sine squared x plus cos squared x is equal to 1. So we can rewrite it that the dy dx is equal to 1 over cos squared x, which is what we are trying to show, basically on that side. So we can write a square box, draw that, or write QED to represent we've shown the proof that was required. Part C, the equation of a curve is given by y is equal to 5x squared minus 7 to the power of 4. Determine the equation of the gradient of the curve. What they're really asking us to find dy dx. So if we use a substitution, y is equal to, let's the brackets be equal to u. So let y equal to u to the power of 4, where u is 5x squared minus 7. Then if u is that, if y is equal to u to the 4th, then dy du is 4u cubed, which is 4 times, we know u, 5x squared minus 7 cubed. And if u is equal to 5x squared minus 7, du dx is equal to 10x, 5 2s are 10, 2 minus 1 is 1, so 10x to the power 1 minus 0. So we have dy du and du dx. By the chain rule, dy dx is equal to dy du times du dx. dy du, we have in green, is 4 by 5x squared minus 7 cubed times 10x. So 4 times are 40. So we have 40x times 5x squared minus 7 all cubed. Right, we have now finished number 4. Let's move on to the second calculus question, right, which is number 5, part A. The region enclosed between y is equal to x squared plus 1. So I'm going to bring up a graph to show you what it looks like. It wasn't given any question. The x-axis, the y-axis, so let's draw a green line to show the y-axis, and a black line to show the x-axis, and the line x equal to a purple line. So those 3 lines we have indicated, x-axis as being black, the y-axis as being green, the line x equal to 2 as purple. Right, so that, let's look at the question again. The region enclosed by that curve, which we have indicated as something that's yellow, right, is now what? It's rotated about the axis. So let's rotate it and see what happens. So let's do it again. Let's do the rotation. Look at it here. You're taking it and you're turning it about the x-axis. So if we turn it about the x-axis one complete turn, we're going to end up with this frustum. And they're asking us to calculate the volume of the solid of revolution that is formed. So we know when we're rotating about the x-axis, then the formula for the volume is pi integral of y squared dx. Dx because it's about the x-axis. And do we know y? Y is x squared plus 1, so we can substitute. So from the integral from x squared plus 1 all squared between the limits of x, which are 0 on the left-hand side and 2 on the right-hand side. So we can integrate as is, or we can expand the brackets first. X squared plus 1 squared gives us x to the 4th plus 2x squared plus 1. We're integrating that between the limits of 0 and 2. So x to the power 4th when integrated is x fifth over 5 plus 2x squared over 3 plus 1x plus c between the limits of 0 and 2. So the volume is equal to pi times 2 to the 5th over 5 plus 2 to the 2 cubed over 3 plus 2 plus c minus, and the values of x are 0 to the 5th over 3 plus 2 times 0 cubed over 3 plus 0 plus c. So all the 0 terms which we have in blue cancel, and we recognize plus c minus plus c. So c minus c is 0, that also disappears. All the terms in 0 cancel, so we're left with the first 3 terms on the right. So we have 2 to the 5th, which is 32 over 5, plus 2 cubed, which is 8 times 2 is 16 over 3, plus 2. That works out to be 206 pi over 15 cubic units. So we found the volume of that revolution. Let's now go on to part B. And this is a kinematics question. So as a particle moves along a straight line, its displacement is measured from a fixed point O on the line. At time t seconds, the acceleration a is given by a is equal to 24t, 24 times the time minus 14. Part 1, find the expression for the velocity v of the particle given that when t is equal to 1, v is equal to 3. So if we know the acceleration, a is equal to dv dt, then we want to find v is equal to the integral of a with respect to t. So, and we know a, so we get a substitute. V is equal to the integral of 24t minus 14 with respect to t. If we integrate 24t, it's going to give us 24t squared over 2, which is 12t squared, minus 14t plus the constant of integration. And we know that when t is equal to 1, v is equal to 3. So we can substitute 3 is equal to 12 times 1 squared minus 14 times 1 plus c. So that's 12 ones are 12, minus 14 ones are 14. 12 minus 14 is minus 2. So 3 is equal to minus 2 plus c. So we add 2 to both sides. We're going to get 3 plus 2 is 5 is equal to c. Thus, the equation for v is v is equal to 12t squared minus 14t plus 5. And for the second part of the question, using your answer in B part 1, find an expression for the displacement s of the particle, given that when t is equal to 1, s is equal to 10. So v is equal to ds dt. As such, s is equal to the integral of v with respect to t. And we know v, we just worked that out in part 1, so we can substitute. V is equal to the integral of 12t squared minus 14t plus 5. And if we integrate t squared, we're going to get 12t cubed over 3. 3 into 12 is 4, so we could write it as 4t cubed. We integrate minus 14t, we get minus 14t squared over 2, which is minus 7t, plus 5 integrated will be 5t plus c. But we know when t is equal to 1, s is equal to 10. So we can substitute into there and find for c. As such, 10 is equal to 4 by 1 cubed, because t is 1, minus 7 by 1 squared, plus 5 by 1 plus c. 4 minus 7 plus 5 plus c. 4 minus 7 is minus 3 plus 5 is 2, and 10 minus 2 is 8. So 8 is equal to c. As such, we can rewrite the equation for s. S is equal to 4t cubed minus 7t squared plus 5t plus 8. Let's move on to part C. The gradient function of the curve C is given by 7 minus 2x. If the curve passes through the point 38, find the equation of the curve. Finding the equation of the curve means that we need to find y. They're giving us a gradient function, that means dy dx is equal to 7 minus 2x. And if we want to find y is the integral of dy dx with respect to x. So we need to integrate. We know dy dx, so integrating 7 minus 2x with respect to x. So if we integrate 7, it's going to give us 7x, and integrate minus 2x, it's going to give us minus 2x squared over 2. The 2's will reduce, so it's give us minus x squared. So 7x minus x squared plus c. But we know it's passing through the point 38. That means when x is 3, y is equal to 8. And if we substitute into that equation above where there are 3 variables, we will know, or 3 unknowns, we have y, we have x, and we have c. Given that we know y and x, we should be able to find c, just as we did in B part 1 and 2. So 8 is equal to 7 times 3 minus 3 squared plus c. 7 3s are 21. 21 minus 9 is 12. So 8 minus 12 is minus 4. Minus 4 is equal to c. Thus, what is y? We wanted to find the equation of the curve. Y is equal to 7x minus x squared minus 4. Let's now move on to the last question on the paper, which is in the fourth section. So number 6 deals with probability and statistics. So the heights of 35 children at a nursery were recorded to the nearest centimeter. The data is shown below: 61, 118 centimeters, 79 centimeters, and so forth. Display the data shown on a stem and leaf diagram. So in a stem and leaf diagram, first of all, we want to set up the idea of what the legend is, or the key. So the key says that if we indicate that the first number is a 10 and the next number is a 8, then it's 108. So if we look at this here, this is the complete stem and leaf diagram. Look at the first number up on top in the raw data is 61. So that means there's a 6 followed by a 1. And if we move across in the second row, we'll see 62. So that's a 6 with a 2. And it goes on, and I've completed the entire thing here. There are 7 5s are 35 items on top. There are 7 5s are 35 items below. Look on the 1, 2, 3, 4, 5th line. You see 10, 3. That means 103. 10, 8, 108. And the next line, 11, 1, 111. Let's now move, since we've completed the stem and leaf diagram, onto part 2. From that diagram, the stem and leaf diagram, determine the median. If there are 35 terms, let's divide that in 2. We're going to get 17, remainder 1. So we will consider 17 and 1, the 18th term, as the median, the number in the middle when they are put in order, either ascending or descending. So if we look at 6 there, 60 what? There's 61, 62, 62, 65, 67. There are 5 terms in the 60s. There are 9 terms in the 70s. That's 5 and 9, 14. 80 is the next term, then 81, 83. So finally, the 18th term, or the median, is 84. We now want to get the lower quartile. The lower quartile means that if we consider all the terms to the left of the median, there are 17 terms. The middle of that 17 terms is the lower quartile. So the middle of that, divide 17 by 2, you get 8. So it will be the 9th term. The 9th term means there are 8 terms before it and 8 terms after it before the median. So if we count it, 5 numbers in the 60s, 70 is the 6th term, 71 is the 7th term, 74 is the 8th term. As such, the 9th term is 75. So that is the lower quartile. And now they're asking us to find the upper quartile. We're going to do the same thing from 86 to 118. There are those 17 terms there. So if we count the 9th term there, it will be the upper quartile. So 76. And then we go to all the terms in the 90s, which is another 8 terms. 1 and 7 is 8 terms. So the next term is 103. That is our upper quartile. In part 3, at another nursery, the heights of the children of the same age were recorded. Another nursery nearby. The median height was 79 centimeters, right? Rather than this height is 84. So that means the average height, right, or the middle height, in this next nursery is 5 centimeters shorter, so the children are generally shorter. And the interquartile range is 24. If we look at our interquartile range here, 103 minus 75 is 28. Compare the characteristics of the two groups of children at the two nurseries and describe one distinct observation about distributions. Well, one you can say is that the the median height is shorter in the nearby nursery, so the children are generally shorter. Or we can say that the nearby nursery children's heights are more uniform, as the quartile range is smaller. It's 24 rather than 28, right? Which is smaller than the 28 centimeters. So more of the children have similar heights. Let's now go on to the last part here, which is probability, to complete the paper. So May 2024, number 6B, part 1. A bar contains 6 red marbles. So let's bring up 6 so you can easily see it. And 5 black marbles. You can do this in the examination easily as well. Quick sketch. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without putting it back, without replacement, for each round. So they're doing that twice. Construct a probability tree diagram to represent this information. So if we have all 11 marbles and we're going to take a chance to pull one, the possibility is that we may pull a red marble or a black marble. There are possibilities for both. But how many red marbles are there? 6 of them. Out of what's possibility? 11. So the probability of pulling a red marble is 6 out of 11. And the probability of pulling a black marble would be 5 out of 11, as you can see by the diagram. Now, if we consider that we randomly draw a marble, let's say we pulled out a red marble, then that would be, we're looking at in the tree diagram there, the upper branch. So we pulled a red marble. Now we have to pull a second time. What can we pull? We can pull a possible red marble or a black marble. Now that we've pulled that red marble, we're left with how many marbles? Not 11 anymore, but 10. What is the possibility of pulling a red marble out of those 10? We have 5 left. So we have 5 out of 10 is the possibility of pulling a red, and 5 out of black, the possibility, 5 out of 10 to pull a black marble. But what happened if we did not pull a red marble, but we actually pulled a black marble? Then, after pulling a black marble, we'll be looking at the branch of the tree diagram below. Then what can we pull as a second selection? We have the options of a red marble again or a black marble from what you're seeing there. Right? How many red marbles are there? 6. How many black marbles are there? 4. So what is the possibility of pulling a red marble? 6 out of the 10, or for a black marble, 4 out of the 10. Let's move on to part 2. Using your answer in B part 1, find the probability that the marbles drawn are all the same color. So the probability that marbles drawn are all of the same color would mean that if we pulled a red with this arrow indicating, we'll have to pull another red. Right? So that's the probability of pulling red and red. Or we can pull a black and another black, because we're pulling all of the same color. We're either pulling 2 reds or 2 blacks. So the probability of pulling all of the same color is the probability of pulling all red and the probability of pulling all black. So how that first 2 arrows up on top for all red would be 6/11 of 5/10, or 6/11 times 5/10. 6 5s are 30, 11 10s are 110. And what is the possibility of pulling all black? Well, that's the 2 arrows below. Lower arrows, we have 5/11 times 4/10. So 5 4s are 20 out of 110. So 30 and 20 is 50 out of 110 is the probability, or we could reduce it to 5 out of 11 is the probability of pulling 2 red marbles or 2 black marbles. We have now come to the last part of this paper 2, where in number 6C, the question says, given 2 events, A and B, the probability of A union B is equal to 0.7. The probability of the event A occurring alone is 0.3. And the probability of B complement is equal to 0.6. Part 1. Calculate the probability of the events A and B intersecting. So let's make a little sketch. We bring up the universal set as a rectangle of all probabilities, and we put a set showing B, that event. Now, if we look at the first line above, what do we know? We know the probability of B complement, not B complement. So let's shade that in yellow. And that probability is 0.6. So we know that the yellow area plus the white area gives us the entire universal set. So an event happening between yellow and white must be 100% certain, which means that the probability of B complement the yellow area plus the probability of B is equal to 1. We can substitute because we know B complements probability is 0.6. So 0.6 plus probability of B is equal to 1. As such, the probability of B is equal to 1 minus 0.6. And therefore, we can solve for B complement for probability of B, which is 0.4. So we can now put that idea that the probability of B is 0.4 into the diagram. What else do we know? If we look at the first line, there are 2 events, A and B. So if we were to represent this on a diagram, we already have B. How do we represent A? Will A be separate from B, totally distinct, or will they be intersecting? Since we're looking at part 1, they're asking us for the probability of that intersection. So clearly, A and B are supposed to intersect. So let's bring up A, and we see a point of intersection, which means that the entire circle of A is 0.3, which is indicated as a blue area and a purple area. And the entire probability of B, which is 0.4, is the purple area and the brown area. So if we were to say probability of A union B, it would be the 3 colors, blue, purple, and brown. However, the probability of A is 2 colors, blue and purple. The probability of B is 2 colors, purple and brown. So if we were just to put them together, we would end up with 4 colors. So we're actually adding the purple area, the intersection area, twice. As such, the probability of A union B is the probability of A, 2 colors, the probability of B, the 2 colors, that's 4 colors, which means we have an extra purple, an extra intersection area, so we have to minus that. Now, what do we want to find? Look at part 1. We want to calculate the probability of A intersect B. As such, let's move it across to the left-hand side because it's negative. So when we move it, it'll become positive. And we want to find probability of A intersect B alone. So let's leave that alone on the left-hand side, which means that is equal to the probability of A plus the probability of B minus the probability of A union B. If we put that in colors, we can say probability of A is blue and purple, plus the probability of B is purple and brown, minus A union B, which is those 3 colors, blue, purple, and brown, and be left with 1 purple area, which is the probability of A intersect B. Now we can substitute accordingly from the first line. The probability of A is 0.3. We worked out the probability of B as 0.4, And they gave us in the first line, the probability of the union, A union B, is 0.7. 0.3 plus 0.4 is 0.7. 0.7 minus 0.7 is 0. So the probability that that A intersect B, these two events, is equal to 0. So let's redraw that. There will be how much in the intersection? Nothing. 0. Which means that when we're redrawing it, we're going to place A at 0.3 and B not touching each other because they do not intersect. Let's see if this follows with what was given above. If the probability of B is 0.4, then the probability of B complement is US, which is 0.6. That's given in the first line. Probability of A is 0.3, also given in the first line. And the probability of A union B, all of A and all of B is 0.3 plus 0.4, which is 0.7. So this supports our diagram above. Now that we've completed part 1, where we would define the probability of the intersection, which is 0, as they do not intersect, let's move on to the last part, part 2. What is the relationship between events A and B? Clearly, event E and event B are totally separate or distinct. So we can say, since A and B cannot occur at the same time, they are considered to be mutually exclusive. So, as we have completed the paper, we have now come to the end of CSEC past paper questions in paper 2. Remember, we did all the solutions from the time this syllabus came out in 2012 up to 2022 by topics. And then we started with May 2023 as a complete past paper solution. And we've now done May 2024. Forget to look at the description down below where we have outlined a guide in how you can cover the entire Add Maths syllabus so that you can get a better grasp of what's happening. Take care, everyone. Bye.